Okay, so at the first example, we don't have really fr or fr plus 1 or fr minus 1 here. Now, so what can we possibly do? We have to use something called partial fractions. Boom. Yes, exactly. Partial fractions. That lesson from calculus is here too. Now, how do we know what to use? Like, how do you know if it's minus, if it's plus, and the denominator or anything? Now, as you know, for to apply that method, we have to have fr, and also we have to have fr plus one. So since the r's are in the denominator, therefore we basically say a over r minus b over r plus 1. Now you may say, okay, but this is not fr and this is not fr plus 1 because basically a and b are different. So, and I'm gonna tell you, are you sure they are different? Look, for the partial fractions to work, they have to be identical, okay? They have to be the same. So fr and fr plus 1 can share the same function. Now let's work. Okay, 1 over r plus 1 equals a over r minus b over r plus 1. We multiply everything by r plus 1, therefore we will be left with 1 equals a r plus 1 minus b times r. Okay, and so we just expand ar plus a minus br. We'll take r as a common factor. A plus b, sorry, minus b plus a. This is the same a here. Therefore, we only want to compare the coefficients, okay? And we will get like between these two, okay? We have 1 and r of a minus b plus a. Like we have only one here. We have 0 r's. Therefore, the coefficient of r is 0. Therefore, a minus b equals 0. Therefore, a equals b, and the constant will be equal to the constant here. A is 1, so b is 1. So as I told you, a and b are 1 by 1. Okay, so 1 over, let me just clear some space here. Okay, therefore 1 over r plus 1 is 1 over r minus 1 over r plus 1, which is basically fr minus f of r plus 1. This is ur, which is exactly the form that we want, fr minus fr plus 1. So no matter what the question asks us now, we can easily and quite frankly solve it. Okay, so the question was sigma r equals 1, 30 of fr minus fr plus 1, which will be obviously equal to 1 minus 1 over 31.